Welcome to my another lecture on singularity. Okay, singularity. This is the second lecture on singularity. In this lecture, the learner will be able to understand the classification of singularity. Classification of singularity. That means how many types of singularity are there in this lecture. You will understand. Okay, so let's see first once again singular point. Singular points I already discussed in my first lecture. Once again, I repeat, that is singular point. If complex function fz is failed to be analytic at z equal to z0, then we say that z equal to z0 is a singular point or singularity of fz. Singularity of fz, that is, if a function, in shortly you can say, if a function is failed to singularity at z equal to z0, that is, if a function is failed to be analytic at z equal to z0, then z equal to z0 is a singular point. We had seen in this this definition in my first lecture very nicely. First you see my first lecture. Now uh, types of singularity, that is classification. Singularity mainly are of two types. One is isolated singularity and non-isolated singularity. Isolated, this is singularity, two types. One is isolated singularity. Isolated singularity, and another is non-isolated singularity. Non-isolated singularity. Again, this isolated singularity again divided into three parts, three types. One is that is removable singularity, removable singularity, then essential singularity, essential singularity, then another is non-essential singularity, or you can say simply pole, or you can say non-essential singularity, okay. These three types, okay. Isolated singularity are of three types: removable singularity, essential singularity, and pole, or you can say non-essential singularity, okay. So firstly, a function will be given. From this function we have to identify whether it has a singular point or not. If it has a singular point, then which type we have to find, that is removable singularity, essential singularity, or pole or non-essential singularity, okay. So to know this, that is removable, essential, and pole, we need to, that is Lorentz series. Using Lorentz series, we can identify removable, essential, and pole. Okay. This part I will do in my next lecture, that is lecture number 3. In this lecture, just we will discuss about isolated singularity. Okay. So if fz is not analytic at z equal to z0, suppose at point z equal to z0, function fz is not analytic, and if z equal to z0 is an isolated singular point, that is, already I know, that is, if fz is not analytic at z equal to z0, then z equal to z0 has a singular point of fz, then fz equal to this is known as actually Lorentz curve, Lorentz series. This is actually Lorentz series, okay. This part is known as general part. This part in Lorentz series, this part is known as general part, general, what I told, general part, and and this part is known as, this part is known as principal part. This is general part, general part, and this is principal part, principal part. So now, what is the function of Laurent series? Using Laurent series, we can identify whether the isolated singularity is removable, essential, or pole. Okay. So which part we will take? For removable, essential, and pole, we have to take always in principal part, not in general part. What is principal part? Principal part means, principal part, it means the value of that is z minus z0, this part, that is, if we take in the numerator, that is z minus z0 to the power minus n, and it is the power of z here is positive, here is negative. So negative part we will take always for getting removable, essential, and pole. The negative power of z is known as the principal part, and the positive power of z of Laurent series is known as general part. So we have to take always in principal part for getting the type of, that is variety of isolated singularity, that is removable, essential, or pole. Okay. Okay. Now I want to talk about what are isolated singularity. Isolated singularity. Okay, in this lecture, the learner will be able to understand that is isolated singularity. So now, what is isolated singularity? This is known as Laurent curve. Be careful. This is known as Laurent series. Laurent, not curve, Laurent series. Okay. Now, what is isolated singularity? What is isolated singularity? I'm just removing this thing. What is isolated singularity? Isolated singularity. Isolated singularity. If there is no other singular, if there is no other singularity, if there is no other singularity in the neighborhood, in the neighborhood of z0, then we say z equal to z0 is isolated singularity. Isolated singularity of fz. This is the actually definition of isolated singularity. Now try to understand about what is isolated singularity. If there is no other singular point in the neighborhood of z, that means if we draw a circle of small radius, that is at z0 is a point, z0 is a point of center of the circle, z equal to z0 is a singular point, I told. Okay. So here we can say z equal to z0 is a singular point. Is a singular point. Okay, is a singular point. Z equal to z0. Now the question is, that is, if z equal to z0 is a singular point, that is, if we draw a circle of radius, this radius is epsilon. Say this radius is epsilon. If we draw a circle of radius epsilon, which is very, very small, and z0, what is this? This is the center of the circle. This epsilon is it is very, very small. Epsilon is very, very small. Very, very small. Okay. very, very small. So then only, that is in this neighborhood, that is in this circle, there will be no other point, no other point of singularity, no other point in this circle, there will be no other point of singularity. That is only z equal to z0 is a singular point. Only z equal to z0 is a singular point. That is no other singular points of fz within that circle, within that circle. In this circle, there will be no other singular point. What is the circle? Circle whose center is z, this point z equal to z0, z equal to z0, and this epsilon is very, very small, whose radius is epsilon, that is around z0. If we consider a circle whose radius is very, very small, then there will be no other point of singularity in this circle. Okay, then z equal to z0 we can say is isolated singular point. Then z equal to z0 is isolated singular point. Singular point. Isolated singular point. Isolated singular point. Okay. Isolated singular point. Z equal to z0. In this neighborhood, there will be no other singular point. Then we can say it is isolated singular point. Okay. Now, condition of isolated singularity for suppose condition. So I am saying condition of isolated singularity. Isolated singularity. Isolated singularity. Put denominator equal to 0. That means when fz is given, how to get isolated singular point? That is how to get, we have to put denominator equal to 0. Denominator equal to 0 to calculate singular point, to calculate, put z equal to 0 to calculate singular point. Singular points. These singular points may be finite, may be infinite. If this singular point is finite, then we can say it is isolated singular point. If this singular point is infinite, then it may be, it will be infinite singular point. Okay. That is non-isolated singular point. Okay. Now, for example, if I take an example, suppose fz equal to 1 by z. You see, fz equal to 1 by z, then fz is not defined when z equal to 0 because 1 by 0 is undefined. So z equal to 0. So we can say put denominator equal to 0. So z equal to 0 is a singular point. Is a singular point. Okay, is a singular point. So because fz is not defined at z equal to 0, this is the condition for isolated singularity. How to get the isolated, that is singular points? Put denominator equal to 0. Here, if we put denominator 0, then z equal to 0, then z equal to 0 is an isolated singularity. Again, another example. Suppose fz equal to 1 by z minus 1 into z minus 2. Say this is, suppose here is z. Okay. So in this example, what is this? This is fz. Okay, fz. Okay, a complex function. So in this function, we see that put denominator 0, that is z minus 1 0 and z minus 2 0. If we put separately, that is this into this equal to 0, that means z equal to 1 or z equal to 2. That both z equal to 1 is a singular point, z equal to 2 is another singular point. Okay, so by this way, we can find the isolated singularity. In isolated singularity, how to get? Put denominator part equal to 0, and you will see here, if we put denominator 0, then fz is not defined. That means in this function z equal to 1 and z equal to 2 are the two singular points. Here z equal to 0 is a singular point. These are isolated singular point. In my next video, this singular point, whether this singular point is essential, non-essential, that is pole, or another type is, that is removable singularity, we will understand using Lorentz series. Using Lorentz series. So we will understand. We will see in my next video, that is removable singularity. That is in lecture 3. You will understand essential singularity. Okay. Once again, I repeat, that is just lastly, that is isolated singular point means if z equal to z0 is a isolated singular point, that is fz is not defined at z equal to z0, then z equal to z0 is a singular point. That means the inner meaning is that if we draw a circle with z0 as a center and epsilon is the radius, then there will be no points inside the circle of singularity, no point of singularity inside the only one point, that is z equal to z0. Okay, so this is known as z equal to z0 is known as isolated singularity. Isolated singularity. Okay, then in my next video I already told essential singularity. Okay, till then, bye bye. Thank you very much.